in this experiment, there are two parts, which is introduction and objective. The first part is the introduction. So what is hydrostatic? Hydrostatic is a branch of fluid mechanics that studies fluid at rest or the pressure exerted by a fluid on an immersed body. So hydrostatic force is the force on the water surfaces when there are no shear stresses on the fluid, or which means that the water is stationary or at rest. And this force acts on the direction normal to each surfaces and is very dependent to the depth of the surfaces. If we move to the second part, which is the objective, two objectives can be highlighted in this experiment. The first one is to experimentally locate the center of the pressure on a vertical, submerged and on the plane surface. And next, the second one is to verify the accuracy of the derived equation from the hydrostatic theory.
In this experiment, there will be two cases to be studied. One is the partially submerged and another one is the fully submerged. So I will show the two cases. So this will be the partially submerged cases. So now we are going to find the depth of the center of the submerged surface. So for the d, we need to find its small d, and we have to find from the water level and minus the bottom level to get the small d, and then divided by 2 in order to get the yc. In order to find the yc, which is the depth of the center of submerged, we need to use the formula yc equals to small d minus big D divided by 2. Small d indicates from the water surface until the bottom of the quadrant, which the big D indicates that the height of the quadrant.
Hello everyone, today we are looking at this equipment in which we are going to measure the center of pressure on a submerged vertical surface. Okay, this equipment consists of three parts. First of all is the balance arm, the weight hanger and the quadrant. Okay. So I'm going to tell you what measurements are we supposed to take. First of all, we are going to measure the length of this equipment, which is from the pivot all the way to the end. Okay. After that, we will measure the radius. The inner radius is taken from the pivot all the way to this part. Then the outer radius is taken from the pivot all the way to this part. Okay. Next will be the height. The height is from this part to this part. Then the width will be taken from here to here. But then, when taking the width, please be reminded that don't measure from the top. Make sure you measure from the bottom, in which you can avoid any parallax error.
Okay, for the procedure, we should measure the length of this balance arm and also find the height of this quadrant. And then we need to estimate the value of the values of the width of this quadrant. Next is we need to make sure the quadrants and the balance arm is all dry. Next, make sure the waiter is empty and is in position. And then close the drain valve on the tank and fill the tank with water until this part is equilibrium with the pointer of this. This will be the beginning of the point for the data. And then place the non-mesh on the weight tray. This should move the balance arm out of the equilibrium. And then slowly add the water without touching the quadrants, and until the part is equilibrium again. Do not use the drain valve over here to achieve the equilibrium. And then repeat the above measurement by using 50 gram increment. And then we need to verify that full submergence of the end face occurs whenever D is equal to or greater than this D. And then when you have finished collecting the data, then there's the time to drain the tank.
Okay, so for my part, I will discuss about the errors that might occur throughout this experiment. So firstly, I will explain about the parallax error. Parallax error takes place while taking the reading when balancing the bridge arm level.
So this error might causes the imbalance of breech arm level will lead to an inaccurate water height reading, which could consequently affect everything, especially the height that was used to be calculated. So in order to overcome this parallax error, the observer's eyes should be perpendicular to the meniscus of the pupil. Secondly, the error that takes place is error due to the instrument and also surrounding wind movement. This error causes the reading to be taken to be affected. Next error comes the human error while taking the reading of the water height. That might affect the height measurement and all the subsequent calculation as well. Last but not the least is the source of error might occur maybe in the possibility of the water splashing onto the balance breech arm while it was poured. In order to prevent this source of error, the precautions that should be taken is to add the water slowly to balance the arm easily so that it won't disturb the level of the breech arm level.
Okay, so now I would like to explain about the application of the hydrostatic force in our daily life. So first is in the design. Like we need to calculate or estimate the hydrostatic force before we design the base of ship to determine the shape of the base of ship, and then next we need to calculate first the hydrostatic force to design the support of the bridge and the water depth. So next, we need to use the hydrostatic force to do work. What work we need to do? That is, first we need to run for the turbine and generate the electricity. And next, we need to build the resolver on the top of the tower, and then to use natural hydrostatic force and transfer the water to the housing area. And last but not least, we need to use the hydrostatic force in the catheter to transfer water and nutrients to the patient.